So my name is Franco Montalto. I'm a professor at Drexel University in Philadelphia. I'm a New Yorker. That's why I'm here. I do a lot of work in New York. I also have a consulting company in New York City that does some green infrastructure and natural areas restoration work. So I sort of wear different hats. But I was told today to speak a little bit to sort of what is happening right now in the realm of water quality improvement in the city and in the region, and to start with some of the regulatory context associated with this. So I put up a picture that some of you, may remember back in the 40s, 50s, 60s, we had our rivers were burning. And so this was the Cuyahoga River in Cleveland, which was sort of a seminal fire that occurred and then after it, there was an article written in Time magazine that got national attention, America's Sewage System and the Price of Optimism. And it goes through almost every great city as a river. The poetic notion is that flowing water brings commerce, delights the eye, and cools the summer heat, but there's a more prosaic reason for the close affinity of cities and rivers. They serve as convenient free sewers. And that's sort of where we were coming from 40 years ago, was that our rivers were sewers, and we had very little control over what water quality conditions were in the rivers. And so, in part because of the public outcry after that fire and other fires, we got the National Environmental Policy Act, or NEPA, in 1970, the beginning of the year, which sort of set the first national policy that required the impacts of activities to be assessed in terms of their impact on the environment. And at the end of that year, the EPA was formed. So December 1st, 1970, the EPA was formed. And then shortly after that, in 1972, we got the Clean Water Act, which is really the regulatory instrument that allows us now to look at and to control water quality in water bodies like the Hudson. So what the Clean Water Act did was establish this goal of fishable and swimmable waters. So that was national priority. We have to stop this sort of contamination. We need to be able to fish and swim in our waters. And you can go back 1 second. So what that did was set up a permitting system that required dischargers, whether they're municipal dischargers, wastewater treatment plants, or industrial dischargers, a factory somewhere, now is required to get a permit for that discharge point. And their focus was on point sources, so the pipe. The focus was, in 1972, on regulating point source discharges. And we do that through a program which is often called the NIPDES program, the National Pollutant Discharge Elimination System. In some states, like New York, it's administered by the state, so it's a SPEEDES program. So you've probably heard about that. But the original emphasis was on point sources. And then in 1987, there was this first revision of the Clean Water Act where we sort of went back to looking at these fishable and swimmable goals and said, you know what, we're not getting there. We still can't fish and swim in so many of our water bodies. And there was this increased recognition that the problem is really more than just the point sources. It's also these non-point sources. So, in agricultural settings, this would be, agricultural runoff, fertilizers, pesticides. In urban areas, this would be stormwater runoff. So what happened, in addition to establishing sort of enforcement of the point source discharges, was there was sort of this beginning of effort to study non-point sources and establish guidelines, which eventually, in the context of urban areas like New York City, in 1994, we got the combined sewer overflow policy, which now uses the Clean Water Act to regulate combined sewer overflow. So now those are included in the permit. So New York City has a permit, it has 460 some odd CSOs. They're now regulated as part of the permit. And initially there were controls. The city was then, this city and other cities were required to develop a long-term plan that sort of spoke to the problem of combined sewer overflows. And I'm not going to go through everything, but there's a very sort of detailed set of characteristics that need to be part of that plan, which includes what you all are doing here. There today, public participation, monitoring, as we heard from Kate, sort of consideration of sensitive areas, particularly contaminated water body. We have to look at different alternatives. And we have to maximize what we can do with the existing infrastructure we have there. So we have sewers and we have wastewater treatment plants. So let's not sort of forget about those. Let's work on those. Let's get them working and monitoring. You can go on. Next slide. So, but what happened sort of initially as enforcement of combined sewer overflow regulation sort of came down and cities started to think about it was, well, you know, maybe the best way to do this is to make the sewer system bigger, right? If the problem is that the sewer system isn't big enough, we can't convey all of this stormwater to the wastewater treatment plants, and as a result, we have these places where it overflows or backs up. You know, the initial thinking sort of on the infrastructure side was how much would it cost to separate the sewers or make the sewers bigger so that we can sort of intercept the overflows. So, you know, sort of implicit in, I'm going to call this the gray approach that we were talking about 20 years ago, even 10 years ago, was that runoff is sort of an inevitable byproduct of urbanization. We want to live in cities, we have to have impervious surfaces. If we have impervious surfaces, we have to have runoff. It's inevitable, and we can't, in the context of a city, we can't reduce runoff. So we looked at runoff sort of the way we looked at other forms of waste. This was something we just had to get rid of. There was no value to it. We need to collect, convey, dispose of it. And we started building this sort of legacy stormwater infrastructure that you see all over the place. We started making channels more efficient, so we'd take streams and we'd line them with concrete so that water that's generated during storms can be conveyed more quickly. We put drains all over the place. It was really this whole idea of getting rid of waste. And we started to see massive projects going in the ground around the country. I'm just going to show one. This is an interesting project in Milwaukee, the Metropolitan Milwaukee Deep Tunnel Project, which Milwaukee has a CSO problem. The thinking there was, let's try to intercept all of these CSOs and send the water into the ground into a very large, in this case 26-mile long tunnel that's only purpose is receive the overflows instead of the water body, and then after it stops raining, we can pump this to the wastewater treatment plant. And you know, you can see it was a massive construction project, and it cost $3 billion, and this is from the Metropolitan Milwaukee website, and you can see this is the millions of gallons of CSOs per year, and then this is years starting in 1990 through 2009. And you can see when the tunnel went online, there was certainly a reduction in sewer overflows. There wasn't an elimination of sewer overflows, you still had sewer overflows, but there was a reduction. But the question that a lot of municipalities started asking was, $3 billion to dig a really deep hole and, you know, disrupt streets and achieve potentially one benefit and only partially, because we didn't eliminate CSOs. You still have discharges, right? But you reduce them. So there was this whole sort of discussion going on about, is this an effective way to use money? And I think that's where people started thinking about other ways. It said, do we have to consider runoff an inevitable byproduct of urbanization? Or can we find creative ways in a distributed way within the city of reducing runoff? So can we limit imperviousness? Can we find ways to send water into the ground? Can we reuse various sources of water? And can we sort of therefore look at runoff as a resource that can help us to enhance our urban ecosystems, which incidentally are also degraded as a result of the impact of urbanization. So, so now New York City in 2009 came up with the Green Infrastructure Plan, and a lot of other cities have green infrastructure plans now, and it involved these key components. So certainly building cost-effective gray infrastructure. So where it makes sense to make the sewer system more efficient, or to make changes to the wastewater treatment plant so that they can process more water, we do that. But then the goal was to control runoff from 10% of the city's impervious surfaces through green infrastructure. And we're sort of well into, several years now into that program. And it's being implemented in an adaptive management way. So we try things, there are milestones, the things that work we repeat, we develop standards, we keep going. And stakeholders are part of that whole process. And there's a lot of money being spent on green infrastructure. And we're beginning to see, and you've probably seen walking around the city, projects like this. This is a stormwater capture Green Street built in Queens that I happen to be monitoring for the New York City Parks Department. So you have runoff from the street going in through a curb cut and being sent into this depression where it infiltrates and goes into the ground. We've done some interesting monitoring there during Irene and Sandy, and this site during those events really infiltrated just about all of the water that came into it. Keep going. The city now has standards for right-of-way bioswales, which are these 20 by 5 typically vegetated areas that you see in the sidewalk space. That's a DEP image. We're monitoring some of these now, but these are going in massive quantities, especially in priority water bodies and watersheds. All kinds of green infrastructure is being built. This is in Jamaica Bay watershed, an enhanced tree pit. These photos are from the DEP website, where you're creating some void spaces below the ground, and the stormwater goes in and it supports things, supports the vegetation of the tree. And a variety of other projects in community gardens, projects on private property. Next slide. Wetlands being built in tight urban spaces. This is in the Bronx. Keep going. And on rooftops. So the Jacob Javits Convention Center, not a few blocks from here, is building, you may know, a 6-acre green roof, which is going to be the second largest in the country. And that's our monitoring station on top of it. Go ahead. So, I guess to conclude, I want to say that we're really at a very exciting time in improving urban water quality, because we're sort of, it's a shifting paradigm. And, I've been focusing on stormwater, but also within the wastewater regime, we're now thinking about, ways of doing more with less. But from a stormwater perspective, we're going from what I would consider, 10, 20 years ago, gray, centralized, and monofunctional. Think of a tunnel that's built in a certain place to achieve one goal, or a very large tank that's built at some point to intercept overflows, really from one benefit costing a lot of money, to this recognition that we can do more with the money that we are investing in infrastructure and water infrastructure, given all of the constraints that we have right now, aging infrastructure, economic issues, and these things sort of ratcheted up regulatory conditions. So we're now I'm saying we're in this world of green, decentralized, and multifunctional. So if you think about that bioswale picture that I showed, that's managing stormwater, but it's also adding some ecological value, potentially. It's maybe even adding some real estate value to your street. And so my last slide, I want to just say that because of the distributed nature of the way we're thinking about the problem now, we're all watershed managers. So this idea of controlling water quality is no longer just the domain of technicians who work for a municipal agency, who sit behind a fence in a wastewater treatment plant that's on the edge of the city that you don't see. Water quality improvements and sort of wastewater and water management is now sort of back in our neighborhoods, and the extent to which citizens get behind this, become part of this, and the city becomes successful in working in partnership with community groups, with neighborhoods, with private developers, at retrofitting, because we're not going to knock down the city and rebuild it. We have to retrofit cities to make them multifunctional. That's sort of implicit in this green approach. And so I just end this with an image of a treadle pump that we put in Newark with Caitlin and with others from HEP. Where we have students from a school who are now using this pump, which is like a Stairmaster, to take harvested stormwater that we get from rooftops that's stored underground and send it into some garden plots that become part of the programming of the school. And actually we have another treadle pump going in the Bronx right now in a housing environment. So we're all part of this process now, and I'll stop there.